All right, good morning. Good morning, Seoul, and thank you for having me here for the first time in Korea. I'm very excited to be here today. You've heard a little bit about digital transformation. You've heard about how Red Hat and open source play a role in that transformation. Let's talk in more detail. How does that affect the IT group in your organization? So this is not just a business transformation, this is practical. There's real implications for the IT groups. And what we'd like to talk about today is building an architecture, a comprehensive architecture for continuous innovation. You hear a lot about every company as a software company, and while that may be a little cliche, it's also true. So an example, Volvo, the car company, has launched a connected car initiative. And it is with this initiative that they're fundamentally changing how they work, how they relate to their customer. So within the car, they're replacing traditional controls with a large touch screen. And of course, that large touch screen is powered by software, a digital asset. So the IT group, still responsible, of course, for back office functionality like email, financial systems, manufacturing systems, is now also a partner with a line of business producing a piece of software that becomes differentiated business value for this company in their market. So this is a great example of software really changing the dynamics of our modern marketplace. And we'll talk a little bit today about how we can build the infrastructure to support businesses adapting to these rapid requirements coming from the market. They're trying to appeal to more customers, enter new lines of business, and in many cases compete with new companies that don't have the same background and can focus completely on the digital experience. So this is not just about the Ubers and the Netflixes of the world, but this is about all of the companies across multiple industries trying to compete in this modern market landscape. So in order to do this, it's a journey. And one question would be, where are you in this journey today? We're focused on achieving some outcomes. The outcomes look like improving speed being time to market. How quickly can you bring something to the market to impact your business? Efficiency. We're constantly being asked to do more with less. So part of efficiency might be as simple as consolidation, more workloads running on fewer pieces of hardware. But another really important component of efficiency is how quickly you can build and deliver your software by using things like automation to eliminate manual touching of different portions of the process of building and delivering software. And ultimately, we're trying to facilitate agility. Agility to respond to rapid changes in the market. Agility to introduce new products that might bring your company into new markets. And the ability to respond to market threats where you have a startup company who's really changing the market dynamics fundamentally. So, digital transformation, what does it mean? Digital transformation has, I'd say, three basic components. First, it's the actual software architecture of the applications that we're building and delivering. Second, it's the platform. What are we delivering this application on? And third, it's the process. How do we build and deliver this application? And I think it's important to note in that process component that there's real people involved, people whose work habits and workflows need to change. And so digital transformation is a combined transformation of bringing new technology, new techniques, new tools to the IT group, but it's also changing the workflow, changing the process, and changing the mindset of the company to align the IT group as a technology department with the business requirements and the lines of business that are really looking to improve on their market, improve their market position. So if we look at the application architecture, traditional applications were built to be put into production and last for quite some time. This is the state of the art for the last decade, and this is what you see pervasive across all data centers. It's an application that may be built as a monolithic application. The process involved was typically slow, a waterfall process. It was designed not to be changed very often. It was designed to be put into production and left alone. And it's that design model or that design philosophy that actually becomes a constraint around agility, the ability to move quickly. So over the last decade, you saw an introduction of service-oriented architecture, trying to address the challenges of a monolithic application where a single change within the application could ripple through the entire application. Certainly, a single bug in the application can take the entire application down. The evolution of a service-oriented architecture is today what we call microservices. And with microservices, we have a technology and architectural approach that is really finally enabling us to realize some core dreams of developers and computer science, and that is the ability to build something and reuse it. So with object-oriented programming, we had the same desire we could reuse an object. With service-oriented architecture, we had the same notion of reusing services. Today, with microservice architectures, we're evolving that same state-of-the-art, building functionality into a single service, connecting services through standard REST-based APIs, and providing some level of orchestration to tie together each of the services into an application. And it's the ability to create a single service with a small team and reuse those services that really gives us the benefits of a modern application architecture so that you can rapidly introduce new applications into your environment. I was just recently with a bank who produced an application from concept to deployment in 6 months. Now, for a bank by itself, that's a pretty remarkable feat because you could easily go from concept to a long product and marketing requirements description in 6 months. But I think what was more interesting in this conversation with this bank was not only that short time to market for the single application, but the next application that they built, they were immediately able to reuse some key components so that the second application goes to market even more rapidly. When you're producing this modern application, you also need consistency across a number of different environments for where this application may be deployed. So if you have designed your application around a specific platform where you're deploying it to, you'll have challenges. So we talk a lot about the 4 footprints being a physical server, a virtual server, private cloud, and a public cloud. The ability to span all of those different footprints with a single application, and in some cases, different components of a single application resident on these different footprints. This is the modern world, and so it's not just about building a modern architected application, but it's about deploying that application to a modern infrastructure, a next generation infrastructure. Call it a cloud infrastructure or a hybrid cloud infrastructure. We've done some surveys with analyst partners and seen something like 90% of CIOs are focused on 3 key strategies here. And one is a hybrid cloud approach, which is saying I'm going to deploy this application to multiple environments. The other is that the application landscape is going to consist of both traditional applications as well as modern applications. And more importantly, those applications need to talk to one another. And finally, consistent manageability and insights into the infrastructure. These are 3 key components for how a modern IT group is going to build, deliver, manage applications. So let's talk a little bit about the process that we use to build and deliver an application. I think we know well the waterfall process, and the waterfall process has it's well structured. It's also, in a modern world, absolutely slow. You have design concepts, which are done by architects, which are handed over in written form to developers who write code, who hand the code over to testing groups, and that entire process, it's just by definition slow. You have expensive handoffs, and by the time you find some bug in the application, you're far away from the point in time that you've actually designed and developed the application. A modern process is an iterative process. It's continually moving, continually evolving, continually refining the application. This can be facilitated with a change in internal structure, but it's also important to have the right tooling. So some kind of application lifecycle management through CI, CD, continuous integration, continuous delivery is a key part to building and delivering applications in a most efficient and rapid way possible. One thing to keep in mind in this sort of iterative process is that it's not just about build, deploy, but there's an operational state where you've built, you've deployed, and you need to keep track of what's going on in your application. So there's a monitoring phase, there's a monitoring step, and that's the place where you're understanding how your application is used and how to improve performance, customer engagement, whatever metric that you're measuring through the monitoring aspect of your application deployment. There's an interesting study from McKinsey that showed an average deployment can go from something like 89 days down to 10 or 15 days by following this modern agile process. So that's a significant reduction in time from traditional model to more modern model in terms of delivering value for your business. So this is, I think, an important piece, which is we've talked about this hybrid cloud. What are the processes that you need to utilize to really efficiently deploy, manage, integrate these applications? A modern application is made of multiple services. It's integrated with different data sources. All of this creates a complex runtime environment. To manually manage that complexity is just infeasible. So we need automation. We need automation tools that allow us to treat components with some similar attributes. The life cycle of a component. You start it, you stop it, you update a version. You can add a new one and update a load balancer so that you've scaled your application. This automation builds consistency and efficiency, And this is part of how an IT department can do more with less. I've spent a lot of time with network operators. Network operators are really looking at systems administrators, IT departments, with a form of jealousy, saying a server administrator today can manage not one, not 10, not hundreds, potentially thousands of servers through automation and tools. And a network operator is still using a lot of manual intervention into the network so that the ratio of a single network administrator to a network box is substantially lower than the ratio of a server administrator to a set of servers. So it's that automation that builds efficiency that allows you to do more with less. We have a customer, Splunk, who started with using Ansible Tower and Ansible playbooks to automate some basic processes of moving applications towards the cloud. And as they gained success with that, I would call these sort of static automations. As they gained success with that, they then looked at how could we do more dynamic control of our environment using the same automation tools so that we can now scale up and scale down applications, again, in an automated way, so it doesn't require any manual intervention. It's an example of the power of automation and how it allows you to span these multiple footprints because you have consistent tooling in any environment. So a cloud-native application or a modern application requires an updated platform. The cloud-native platform is, it's something that's really driven through APIs. It allows developers to allocate resources. It's giving control to the developer while retaining some platform guidance from the operations team. And this is really kind of how do we give developers control without losing overall control over our environment and potentially concerns around compliance. It's a lightweight platform. It needs to be modular. It needs to work with a different variety of processes so that you have some say about how you build and deliver your software. What does your CI/CD pipeline look like? It needs to be capable of integrating multiple applications, multiple data sources. And I think one of the key important things to consider here is it's not just internal applications. A modern web scale application is making more and more use of external services. You see software as a service is a big part of the modern software landscape. And so for your application to take advantage of reusing internal services but also external services is going to be critical to your ability to move quickly. You're building only your business differentiated value, not spending time building, re-architecting and building common tools that may already be out there. So this platform also enables consistency across each of the footprints. And this is something that we saw with Linux, with Red Hat Enterprise Linux in the early days. You have a variety of underlying hardware providers. You've got a data center filled with a heterogeneous hardware environment, and something like the operating system creates consistency across all those pieces of hardware. In this modern world, the platform is a data center, it's a cloud, private or public, but we still need that consistency across each of those footprints. We still need to be able to efficiently manage and view the applications as they're deployed, regardless of the target deployment location. And so it's this platform, this cloud-native platform, that builds a modern consistency akin to something like Red Hat Enterprise Linux. Certainly Linux is at the base of these platforms, whether it's something like Red Hat OpenStack to build modern infrastructure, or whether it's something like the Red Hat OpenShift platform to build this modern application platform. Each of these are built up from Linux and provide a level of consistency across each of these different footprints that allow you to take advantage of the automation tools and the agility, and get the agility that your business is striving for. So each of these things that we've talked about, it's the software application architecture, it's the platform infrastructure, these cloud-native platforms, it's the process, the DevOps process, the move to a more agile workflow. Each of these things work together. So a DevOps pipeline is taking advantage of a CI/CD system is taking advantage of APIs in the underlying platforms. It's used to deploy a service. The platform is tying together a collection of services. All of these things work together and support one another. And this is the journey. And this is the place where you can start really at any point in this way. I usually look at it from the point of view of starting with DevOps, starting with changing internally how you build and deliver software, because you can find efficiencies with traditional applications by simply virtualizing or containerizing them to create consolidation and to create the accessibility of automation tools around lifecycle management for those traditional applications. It also gives you the building block for tying those traditional applications with the web scale modern portion of your application, so you can provide some level of service interface to existing core business logic like a transaction processing system, while still retaining the independent, scalable development process for building, say, your mobile web app. That's where you're directly engaging with customers, and that needs to change rapidly despite the fact that your transaction processing system on the back end may not have changed in literally decades. I was recently in Australia speaking with two separate customers who didn't realize it, but they were actually arguing with each other by telling me each that they had the oldest mainframe in Australia in production. Code that hadn't been touched in, say, 30, 35 years, and needing to interact with external systems, providing, say, that mobile footprint to customers. A very concrete example. So if you tie it all together, you saw this from Jay, you get this architectural perspective from Red Hat, which says there are multiple layers in the stack. There's an infrastructure layer, where you'll find things like Linux and OpenStack, and Red Hat Enterprise Virtualization and consistent storage across each of these different platforms. You find a container platform layer like OpenShift. You have a set of middleware and application services coming from our JBoss portfolio. You have security and management tools so that you can get good insights, consistent visibility into the infrastructure, understand what your applications are doing, where they've been deployed, and a set of developer tooling that gives the developers what they need to actually build and develop the applications. It's a very comprehensive view. I think it's a great picture that shows the breadth of what Red Hat is building. So with that in mind, what does the future look like? The future, well, looks bright. The future is a future of continuous innovation. It's this rapid iteration, this release early, release often mindset that we found in the open source communities. And let's take kind of a quick look at what an application lifecycle might look like in this modern environment. So this is net new. We've been talking with a line of business. They've come to us with a business problem. We're building a new service. You have some initial questions to answer for yourself. What frameworks are you going to use? These are developer choices, certainly informed by experience, by skills. In our world, we see a lot of Java development, so let's assume a Java application is what we're trying to build here for this service. You look within the Java world, and you have a number of components that we can build into this application, messaging to connect it to other components, business rules, business process management, things that we can bring together to build this initial service. A great way to package this service is using containers, and this would be intrinsic to the OpenShift container platform. You have a layered approach with containers where you have this base image, which would be derived from Red Hat Enterprise Linux. You can have application runtime specific contents, like a Java runtime, a Node runtime, and then layered on top of that, you have real specific application logic. It's the containers that build consistency in how you to move this application around your different deployment environments. And it's containers that provide some separation of duty between the low-level infrastructure and the higher-level application logic. So you build your code in your local environment. One thing that's important is if you're using containers, there's a number of tools you might be interested in looking at. Ultimately, you want to make sure that when you're building and deploying the service in your local environment, you have some consistency with how it goes into test and how it goes into production. So we have OpenShift Local, which allows you to build and deliver this portion of the application directly within your local environment as a developer. And then you move to a next phase of collaboration with other teams where you're bringing together multiple services, delivering this in some kind of a test environment where you would use OpenShift Container Lab. And ultimately, we're going to send this into production on the OpenShift container platform. The consistency in each of these environments, independent of the target platform, your laptop, a public cloud, your internal private data center, this is what helps you build to scale. Now, it's not just the development side. There's an operational view of the world as well. So we have this next generation application. We built a service. We've integrated it with other services to develop the application. And, well, there's a vulnerability somewhere. And the operations team has been made aware of, say, a Heartbleed type vulnerability. What do? We need, first of all, to understand where vulnerable container images may have been deployed. We'd like to understand where these images came from. So is this certified content from a provider like Red Hat, or is this untrusted content that you can't really attest to the provenance of? The next phase after identifying the vulnerability and understanding where this vulnerability has been deployed is to go into a remediation phase. In this remediation phase, the operations team has some choices. Depending on the type of vulnerability, it may be in the base image, and this may be something that the operations team can refresh the base image, can recompose the application, which again is that layered application, and redeploy using whatever deployment methodology, whether it's a canary type methodology or a blue-green methodology, to slowly introduce the change into your environment in a very careful and prescriptive way. Or potentially, the vulnerability is something that requires some actual application level changes, and the application developer can be involved. The application developer updates the application in concert with the changes to the image, and again, that redeployment through the deployment methodology of your choice is the final phase of first identifying the vulnerability and then going through and updating your infrastructure and rolling out changes so that you're no longer vulnerable to this security concern. So it's with this set of platforms, or with this set of tools, that we can help our business move at the speed we've wanted to, where in the past we felt constrained by things like monolithic applications, things that are really designed to run for decades, not be put into production within weeks or days, or in some cases even hours. It's this consistency across the different footprints that gives you agility. It's this consistency across different footprints that enables automation, all of the things that we've just been talking about that I think we've seen our customers put into production and create real value for themselves. There's also an operational view that has these operational components: Satellite, CloudForms, Ansible Tower, and Red Hat Insights, giving you the tools you need to manage your images, understand where they've been deployed, give automation around the creation and deployment of those images, and insights into your infrastructure. So again, the future looks bright. This is the next generation IT infrastructure. It's a combination of tools, developer processes, automation tools, and we're fueling innovation for your business. And we have a lot of experience at Red Hat in both the operational side, working with IT groups with a tool like RHEL, and the developer side for 15 years, and the developer side with a tool like, or with a suite like JBoss, really focused on improving developer productivity and operational efficiencies for quite some time, and we're taking this experience and moving it into the next generation infrastructure. It doesn't stop there. We keep moving, we keep innovating. We're working within this open source world where open source innovation, open source is a source of innovation. So we continue to look for, identify, and bring to our customers new innovative tools. And so, well, in one way that we're changing how we operate with our customers is bringing more and more of these components together in a cloud suite, so it's an infrastructure as well as a platform, co-resident plus management. We have a mechanism for helping you take your applications today and move them into this cloud-native environment. So it's how can you re-architect? How can you move your application? It requires some training, some services, some assistance. We've built up a practice around that called the Innovation Labs. And of course, you saw recently an acquisition we did bringing API management to the Red Hat product portfolio. Important to note that this future that I'm talking about, this future is today, it's now, it's in real production in our customers' environments, and it's giving them business value already. A couple examples here, using OpenStack, both in a betting exchange to increase their ability to introduce new functionality to their customers and increase the number of transactions that they can process with reduced downtime. So a modern application environment. A retailer, again, using OpenStack and DevOps methodologies to build not just next generation applications, but also consistency across different footprints, from mobile to in-store, so that customers get a really comprehensive experience. And a company in the travel industry moving to containerizing their applications on OpenShift, enabling them to support their customers in entering new lines of business to get into new markets faster. So this is real. We're seeing improved time to market and decreased costs, which is exactly what businesses are looking for today. So this is the new foundation for continuous innovation, and it's built on open source, it's built on collaboration. And I think one of the things that hopefully you'll have some time today in the breakout sessions is to dig deeper into each of these components and hear how these tools can be accessible to you in your environments and help you impact the business change that we see all of our customers are looking for. So again, thank you for listening. Thank you for hosting me in Korea, and I hope you have a great rest of the day. Thank you.